Hello everyone, my name is Austin Shaner, and welcome back to my channel. In 3D design, there are really only two primary schools of thought, bottom-up or top-down design. The conventional method for most 3D programs is bottom-up, which means that you create each part individually in a separate part file, and then bring them all together into an assembly file in which you can create relationships between components by joining or mating them together. This is extremely useful when dealing with complex designs or large assemblies, as our program does not need to recalculate every part in your assembly each time an individual part has been modified, but merely change its position in space. This method does have its drawbacks, however. When you need to make changes to an individual part, you must first open that part separately, make your change, then go back to your assembly and update it. This not only makes the modeling process slower, but also introduces more opportunity for dimensional mistakes, as the other components in your design may now need to be updated as well. The other school of thought is top-down design, where you start with the assembly file and then create each component within the context of that assembly. This means that the dimensions of parts can be more readily driven by other features or components in your design. This is extremely useful when building parametric shapes and features, and can make life much easier for developing new products when you may not know exactly what the dimensions of any given part should be. The drawbacks to a top-down approach, however, is that it can be very resource intensive. All dimensions are contingent upon all other dimensions and locations of features in your design. This introduces more opportunity for calculation errors, because when you change the dimension of one feature, the other features that were dependent upon that dimension may now be impossible to create. All that being said, there's really no correct method here. Each have their pros and cons, and the approach you should use depends on the design you're trying to create. So for this reason, programs like SolidWorks and Fusion offer a sort of hybrid approach to this, but each specialize in one particular method. SolidWorks primarily uses a bottom-up approach, while Fusion 360 primarily uses a top-down approach. Both SolidWorks and Fusion offer the ability to do either, but they're both somewhat limited when out of their element. So today I would like to cover how you can implement both a bottom-up or a top-down approach in Fusion 360, and what key things you'll need to pay attention to as you generate your design. So let's not waste any more time and dig right in. Okay, so jumping into Fusion, we are going to cover primarily bottom-up design today, because Fusion 360 is natively a top-down design software, so most of you are already using a top-down approach in your designs. So what we really need to figure out is how can we utilize a bottom-up approach to enhance our designs and make modeling changes between different designs much more streamlined. So what you see on the screen here is a water cooling loop that I developed for a friend of mine. He wanted a water cooling loop in a computer based up around the Aquacomputer Aquatube reservoir. It's a very old reservoir in the market, and it's still to this day one of the most unique and interesting ones out there. And he liked the design so much, he wanted this kind of like industrial / steampunk vibe to it. So that's what we're going to do. Now, we're not going to model the entire thing because we don't have the time for that. But what we are going to focus on is this reservoir right here. So that's what we're going to be building today. And if I pull this up, you'll see that it offers a pretty good example of both bottom-up and top-down design. So I have top-down by building this component and some like this glass right here that goes on top. But then we have bottom-up by inserting a bunch of fittings and screws and all the little things that connect to it. And so I'm going to show you how you can reuse those between designs. Okay, so I've opened up a new design and we're going to sketch on the top plane. Now I'm going to create a circle representing the outer diameter of this reservoir. So we're going to do 100 millimeters. And then we're going to create another circle that represents the inside lip where the glass is going to sit. So let's do 92 millimeters. And then we're going to create one more, which is going to represent the main bore into the body where the fluid is going to sit. So we're going to do 70 millimeters. So now we can just use this to create a cylinder. So select all three, solid, extrude, I'm going to go down negative 100 millimeters. And then if I bring back my sketches, I can take these two, or I can just take this one, doesn't matter. Extrude it down, and we're going to go down 6 millimeters. And then I'm going to take this one, and I'm going to extrude that down to object, this bottom face right here. And then we're going to offset negative 12 millimeters. So that way we create some material on the bottom there, so that way we have some strength. So hit OK. And that takes care of the main portion of the body. So now what we need to do is create those little ridges that you saw. So I'm going to insert a new plane, an offset plane from the top. And I'm going to go down negative 12 millimeters. And I'm going to sketch on that plane. And then I'm going to project in this outer edge. So let me hide the bodies real quick. So we have that outer edge. And so now we're just going to offset that by negative 2 millimeters, which will give us the depth of the recess for those ridges. Then we can select this line, or this face, and then, or not face, profile. Bring up our body, and we go solid extrude, and we'll bring that down negative 3 millimeters. So that will give us our first ridge. And so then we can go ahead and do a pattern. So we'll go rectangular pattern, and we're going to want to select this feature. So let's change it to features, and then select that again. Directions. What we want to do is we want to go in this direction, so in the Z, and we want to do extent. So we need to figure out what is the depth from here minus 12 millimeters. So I'm going to do a quick guess, and then we'll measure and compensate. So let's go ahead and do extent, and we'll go negative 70 millimeters. Or sorry, positive 70 millimeters. No, it should be negative. There we go. Let's do that real quick, and let's verify what our heights are here and compensate. So we've got 15, so we're 3 millimeters off. So let's go back here, and let's go 73 millimeters. Let's inspect that now. So this should be 12 millimeters. Yes, so we are good. Okay, so now we can come back in and update the quantity of the ridges until they look roughly equal to each other. Let's keep going. Almost there. That looks pretty good. So those look roughly equal to each other. Hit OK. And there we go. So now we've got those ridges or fins, whatever you want to call them. They kind of look like a heat sink. And so now what we need to do is we need to create the flat spots on the side, so that way we can have G-quarter fittings going through. So I'm going to create a new sketch on that same offset plane, like that. And then we're going to project in this inner line, or this inner line right here, hide our bodies, and we're going to create a square that is tangent on all corners of that. We'll go tangent, 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 and one more. There we go. And then all we need to do is give ourselves another rectangle. So we can either do add another rectangle, or we can do offset. So let's do that since it's easier. And we're going to offset this by like 1 inch, just to give ourselves a profile that we can use to cut with. So hit OK. And then we'll select that, bring our body back. And now what we can do is go solid extrude down. You can see it's creating those flat spots. And we're going to go to object, this bottom edge right here. So we don't want it to go past that. Hit OK. And now you see we've got all 4 sides with the flat spots, so we can add in those fittings. So let's create a sketch on the side profile here. So that way we can go ahead and get the geometry we need to place a G-quarter fitting onto. So I'm going to project in these 2 lines right here from this body. And I'm going to create 2 lines from here to here. Actually, I think I'm going to end up creating 3. Like that across. And we're going to make all these equal. Let's make these construction lines. And now we can create a circle or a point. In fact, let's just do a point. We need to set the point where these fittings are going to go. And so now we have a sketch that we can drop a hole feature onto. So if I hide this or finish it, and then I go to hole, I can click on each one of these, and it will locate on those points, and then I can change it. So to distance, we can go to object, the inside face of this bore. And then what we want to do is we want to come up here and say, well, nope, we want a simple hole. We don't want a counterbore or a countersink, but we do want it to be tapped. So now when we click tap, it gives us the ability to define what is our thread pitch or what is our class of thread. So we're going to go thread type, and in this case, it's a pipe thread. So I think it's British Standard Pipe Threads. I think that's what BSP stands for. So we'll go BSP, and we're going to go 1/4, and that gives us our 1/4 inch thread. Right hand, and here's a really important tip when you're doing holes is, do you want it modeled or not modeled? So modeled means it's actually going to cut that thread into the actual part design, but that creates some challenges later on when you're trying to join or make components together. So typically, it's fairly good design practice, unless you actually need it, to not include the threads in your model. And most, like the drawings and everything like that, will still recognize them as G-1/4 threads, but you don't end up having the actual curvature in there. So I'm going to not have them modeled and hit OK. And so now we have our first one, and we might adjust the distance here in a second. But now we just want to basically create a circular pattern of this feature to the top, side, and bottom. So we can come up here and hit create pattern, circular pattern, and we can do type, features, and we want to circular pattern this hole. And then what is the axis? So the axis is going to be this one right here. It looks like it's not quite right. No, yes it is. And so we want 4. So there you go. So now you see that we have 1 on each side, and we can just hit OK. And it didn't show up. Let's go back. I think we need to change it from adjust to optimized or identical. So let's try optimize. There we go. Yes. So it went ahead and included those in there. So now we actually have the whole pattern in there as well. So I did just double check my design, and I need to increase the spacing between these two. So we're going to go back to this sketch right here. I'm going to take off the equal constraint off of this middle line right here. Let's take off all the equals actually and just make just these two outside ones equal. But this middle one, we need to be 35 millimeters. Hit OK, and you'll see that the rest of the design has been updated. So that is now what we want. So moving on, what we need to do now is create the bolt pattern for the M3 screws that will secure the glass on the front in place. So we're going to select create sketch on this plane right here. So that's where the holes are going to be threaded into. And then let's go ahead and create a circle from the center point. And we're going to make that 83 millimeters. So 83 millimeters. And this is going to represent where we place our first hole. And then we don't need to really place the others because we can just do a pattern around. So I'm going to create a circle here. In fact, let's just create a point like we did before instead of a circle. We'll do point, and we'll make these two vertical. So it's at the top of the circle, and then hit finish sketch. And now what we can do is go create hole, and we're going to do the same thing. So we just want a simple hole. We want it tapped. We don't need any offsets, and it's fine if it's the end of the point is angled. And then what we want to do is go to ANSI metric M profile, and we want to do 3 millimeter by 0.5. Hit OK. And so now we have the first threaded hole, and it's got the threads in there. And now what we can do is create another circular pattern. So we'll go pattern, circular pattern, and we'll use this feature along the center axis again. And we want to set the quantity to 8. That way we get a nice little distribution across each one. Hit OK. And the last thing we need to do is create a little O-ring groove, so that way we actually provide a seal for the glass, and then we'll start inserting some different components. So we are going to sketch again on this face, and we're going to project in this circle, and then we're going to offset that. So let's hide this real quick. We're going to offset that by the amount of the wall thickness we want to have around the O-ring. So let's do 1.5 millimeters. And then we're going to offset. You can't offset off an offset line. It's really quite frustrating. So you either have to add that 1.5 millimeters into the dimension you want, or you draw another circle dimensioning off of the previous one. So that's what we're going to do. So I'm going to do this, another circle, and I'm going to dimension between these two of 2.2 millimeters. And let's bring back our bodies. Make sure we still have enough room here. Yes, we do, so that should be good. And let's select that. And we're going to extrude it down 1.3 millimeters. That's I went the wrong direction. Negative 1.3 millimeters. Okay, I need to change it to cut. Sorry. There we go. Okay, so now we have our bolt pattern, we have our little O-ring groove, and we basically have most of this modeled up now. So far we have neither done top-down or bottom-up approach. Right now, this is basically, it could be an assembly file, or it could be a part file. So what we're actually going to do is we're going to turn this into a sub-assembly file. Now, the first part we're going to do is actually top-down. So we're going to create a new component based off of the features in here within the same file. And so that means that that is a top-down approach. But then we're going to go bottom-up and add in the fittings. So let's create a new component, and we'll call this glass. And then what we're going to want to do is sketch on this plane, and we can project in this line, outer line right here. And actually, let's project in these circles right here, like that. Come on, select it. A couple more. Okay, project those in, and that'll give us our base hole, and we can then extrude that up to object this feature right here. Okay, actually I apologize, we don't want to have those circles in here, so I'm going to deselect them from this. In fact, actually, let's just go back to that, delete that extrude, go back to the sketch, and we're going to delete all of these. I apologize about this, because what we're going to end up doing is we're going to end up creating another pattern of a different type of bolt hole, so that way we have a clearance hole rather than a threaded hole. So the diameter of this right now is wrong, so we don't need that. So hit finish, and then we will bring back that sketch. Sorry, that sketch is in here. And we will extrude that up to object, the top face here. Hit OK. And then you'll notice, because now it's a component, it can move. It's not tied to this at all. So what we need to do is we need to join it to this inner ring here. So what you can do is you can select each edge that you want to mate together or join together, like this one, and you can hit J on your keyboard, or you can come up to Assemble, Joint, and it will automatically snap to the center point of both faces, which in our case works out great. But then you can either rotate it or move it as like an offset from that face if you wanted to. So we're just going to say 0 and be good. And then we're going to go ahead and sketch on that top surface, and we're going to project in that little point right here to that top surface, because that gives us our center point of our first circle from the previous bolt pattern. So now I can go ahead and create a hole on that point, and then we'll do another circular pattern wrapping around. So in this case, we don't want a counterbore or a countersink, although we could do countersink. We can just go ahead and do a simple hole. And then we're going to do a clearance hole, not a tapped hole, because we need the bolt to pass through it. And then we can just do flat. And let's hide the body. And we're going to go distance to object, the back surface of this piece of glass. And then on here, we need to come back and select M3, clearance hole, and do we want it to be a loose fit, a tight fit, etc.? We're going to say a close fit. That's going to be a tight fit, so that way we get less chance of mispositioning this. Hit OK. And now we're going to do one more circular pattern. So let's go create pattern, circular pattern. And we're going to do features this hole around the center axis. And we're going to do quantity 8, which will match up with the one we did before. Hit OK. Let's bring back our bodies. And it's kind of hard to see right now, but you can see that we are concentric with the two holes, the inner hole and the outer hole. And so let's go ahead and make this transparent so that way we can kind of see through it. So hit A on your keyboard for appearance, and we will type, let's do acrylic. Acrylic clear, like that. And now you can see, we can see through it, but we still have that face there. So that is good. So before we do anything else, let's save this. And so we're going to save it to, let's open this up. What we're going to do is we're going to create a new project. And we'll talk about this more in a second, but we'll do new project, and we will type reservoir or water cooling loop. We're going to save it inside that project. So save it there, and we will type reservoir. Okay, so we can now that we have that saved, we have the option to either utilize this as a standalone subassembly of two components, or we can insert components into this design and further add to the subassembly. So right now, I'm going to go ahead and further add to the subassembly. So we still have kind of a bottom up, but I'll show you what I mean. So if we go insert McMaster car component, this is a really amazing feature and one of the main reasons I love Fusion 360, because I don't have to model bolts and I don't have to model washers or all the little add-ons that you can get on McMaster. I can just directly import them into my model. And first of all, thank you, McMaster, for having nearly all of your components on your website 3D modeled and available to throw into my design. That has been amazing for me. So we're going to go screws, bolts, and we're going to do M3. So let's go M3 by 0.5 thread pitch. And we're going to do a socket head cap screw. So we're going to do socket. And let's just do stainless steel. And let's do low profile. And let's see if there's anything else we need. The length. So we need to inspect the length real quick. So I want it to be 8 millimeters long. And let's make this a little bit bigger so we can see it a bit better. So we have two options here. What are the differences? We have coarse, fully threaded. I'm not exactly sure what the difference is between these two. Oh, super corrosion resistant 316 stainless or 18.8. Let's do 316 because this will see coolant and we don't want corrosion getting in our coolant or anything like that. So let's just click on this item number, go to product detail, or you can click right here. It looks like they've added this recently. And you can say, do I want to download this directly into SolidWorks, or do I want to download it as a step file into what other CAD program I'm using? So Fusion 360, it's best to just use a step. So we can go 3D step, download. And that's going to insert this bolt into our design. And then we can join it to this piece of glass. Now, this is still basically top down, not bottom up, because this bolt that we've inserted only exists within the context of this assembly. It doesn't exist in any other files or folder structures that I have on my computer. So I can't really reuse this between different designs. So this is an important thing to remember. If I know, let's say I'm going to be building different versions of this and I want to reuse this same bolt between different designs, it might be a good idea to download that as a step file into its own part file. So that way I can add it to my library here and insert it into future designs. But if it's only going to exist within this one design, then it's probably not that necessary. But let me show you how you would do that. So let's go to our water cooling loop. So we have our reservoir here, and I'm going to insert this item number. So I'm going to copy this real quick so we don't have to search for it again. And we're going to create a new design. And let's save it real quick because you can't insert things that aren't saved already. And we are going to save it to the water cooling loop. And we're going to do M3 by 8 millimeter. Hit save. And we'll go McMaster car component. And I'm going to search for that item number. Hit OK. And I'm going to download 3D step into this file. Hit OK. And then we're just going to save it. So now if I pull up my water cooling loop folder, so let's go back to water cooling loop, you'll notice that I now have both my reservoir and this bolt here. And so what I could do, and I like to do this, and I'll show you more about this in my computer file, but I like to create new folders where I can save commonly used parts. So I will do new folder, bolts, and then I can drag that. I might need to close it real quick. Okay, well, let me drag it so you can right click and hit move. And we're going to move it into the bolt folder. So now I can save any bolts that I'm going to be using for this project or any other project like this in this folder. And so let's go ahead and delete this file right here. And we're going to insert that bolt into this design. So now I can open that up, drag it in, and now I have my bolt. And then I can, let's rotate it around and let's join it to the first one. So let's go top. We want to do this one. So I'm going to grab one of the circles on it, and I'm going to grab this circle up here, and we're going to hit J on our keyboard and join those together. Now I have two options here. I can either insert another bolt and then rejoin it, or I can do a circular pattern of this component. So let's try doing it that way, because everything you add to the timeline is going to increase the complexity of what Fusion needs to calculate when you make design changes. So we're just going to do a bolt pattern. So create pattern, circular pattern, and we're going to do components, and we're going to select this one if we can. Let's see. Let's hide the other ones. Let's hide those bodies. Component. Will it let me select it? Maybe. Hold on. Okay, so it just wasn't letting me select it, but I can select it from this design tree right here. And we'll hit that, and then we will go axis on this axis. And so now you can see we have our bolt starting to show up. So we're going to go quantity 8, like that. Hit OK. And let's bring back our other bodies. And let's bring back the main hole. Okay. Okay, so I made a mistake, and what it's doing is it actually added in 8 of the whole glass and the bolts. And that's because I inserted this component into this top level component of glass. So I actually need to undo that. So let's undo this pattern. Go back to our main timeline, and let's delete that one. And so now we're just left with this component insert. So let's delete that component insert, and let's shorten this up, and let's go make sure you're clicked on the highest level assembly file right here. So not this component, but this one. And now let's insert that into here. So now it's going to insert it underneath glass, but not inside glass. And that was the problem we ran into. So let's rotate this around, and let's rejoin it. This bottom ring right here to this one, join. And now let's do our circular pattern. So pattern, circular pattern, components, and we're going to select this component right here, along this axis, and we will do 8. There we go. Hit OK. And so yes, now we have 8 bolts rather than 8 bolts and the glass. So that fixed a little mistake of mine, so I apologize for that. So let's add a new component, and we'll call this hardware. And what we can do is we can drag all of these into that component. So now that is its own component where I can hide it and modify it, move it, etc. And so that is an example of how we went top down from building this body and building this glass to bottom up by having a separate part file for this bolt and inserting that and making a circular pattern across our part. So now what we're going to end up doing is going through and adding some fittings to this to match what we did match what I did for my design. So let's go back to my PC folder, where, as you'll see, I have a lot of folders with a lot of different files. So like I have different sizes of radiators, I have different sizes of fans, I have different fittings. And so in here, this is like the G-quarter fittings that I would end up installing on this reservoir. So I can either just drag these in directly from this folder, or I can create a new folder for this project for fittings. And then I could create a copy of these into that folder if I wanted to. So let's just assume that I went ahead and created these in that folder. And we can drag these into here. What you could also do is if you needed to create a new folder, you can hit upload, and then you could upload any file that you download from GrabCAD or Thingiverse or anything, drop it in there as a reusable component, and then all of this will still apply. So let's do a G-quarter. Let's look for straight hardline fitting. So we'll use this one, and we'll drag that into our design. Okay, so this is an interesting thing to think about. It says designs inserted from another project will not be linked. Components from the selected design will be copied into this design. So what that means is that it's turning it from a bottom up into a top down, which means that part will only exist within the context of that assembly. And if I went back and updated something in this fitting, it won't be linked and won't update in this design. And so if I actually hit cancel on this and I bring up my hardware, you'll notice because we dragged in the bolts that there's a little link icon right here. That means that the dimensions and colors and everything of this bolt are linked to that original part file. So if I right click and I open that part file and I change, let's say the color of it. So let's go red real quick. Let's just drag that on there, hit OK, save, and I bring it back. You'll notice all of these have a little hazard symbol next to it. And that means that component is out of date. It needs you to come up here and click the update button in order to bring in those changes. So if I click that, you'll notice that now all of those have turned red, and that's from a change that we made in the original part file. But if you didn't want that to happen, so let me go back and hit save. Like that. Go back and let's update it again. So now it's back to normal. And if you didn't want that, you could, and you wanted to turn this from a bottom up into a top down design, you can right click here and say break link. And what that means is if I break the link of that individual part, let's see here, it didn't want to break that. That might be because that is the top one. Let's try this. Break link. Okay, it's not letting me do that because it's a circular reference, or not a circular reference, but a circular pattern. But normally, if you're inserting a design and it's got a link, you can right click and hit break link, and then you can make changes to that part within the context of this assembly without impacting this original file. So this one will always remain constant, but maybe just one of these bolts, I didn't want to have the hex on here and I wanted to fill in that gap. I could break the link on that individual part and then make modifications. And so that's really important to remember. So let's go ahead and let's copy this over. So let's create a copy of this. And we're going to bring it into our water cooling loop. And we're going to create a new folder called Fittings. And inside Fittings, we're going to make a copy of that. So now if we go back to our Fittings folder, or not Fittings, water cooling loop folder, and inside Fittings, I have this. So now that this file is in the same project, I can drag it in and it will be a linked reference. So I dragged it into the hardware one. And let's just move this out of the way a little bit. And then we will create a joint on that. I think that represents the O-ring. So we will create a joint right here to that. Now it's flipped by accident. So let's click flip and hit OK. You'll notice that did insert without the error message, and it has the link here. Now, if I right click and say break link, it allows me to break it. And so even if I come in here and I open up this file, and let's say I change this to red, again, let's do the same thing. Hit OK, save. The stupid editable documents. Thank you very much, Fusion 360. Okay, let's hit save. And then I come back in here, and you'll notice it hasn't detected that anything has changed because there is no longer a link between this item and the original document. So we broke that link. So if I undo, you'll notice when I hit Control Z, it now says that it's out of date. So if I update that file, all of a sudden it's red now. So I come back, let's undo that, save. Let's see, save, yep. And let's undo again, update it. Okay, it's wanting to pull that in there. So let's go ahead and just delete this file and bring that back in. So fittings. It didn't save. Ah, okay. It created a new part file. Weird. So let's open this back up. Okay, I'm gonna have to recopy that. I screwed something up there. I'm sorry. Now I won't have to recopy it. So let's just unassign and delete that right there and go steel knurled. And then I think steel satin was on the internal faces there. And on these faces. So let's actually just do body, steel satin, and on faces, we will have that face, and that face, and that'll be good. Okay, let's hit save, go back to our reservoir, update it. Okay, we're back to normal. Sorry about that. I must have screwed something up somehow. So let's rejoin this. Oh, I need to flip it. I forgot. Edit. Joint. There we go. Flip. Okay. So now we're in a position where we could go one of two directions. We could either bring this into our computer file and then start creating the pipes from there. Or we could create the pipes in here and bring all of that into the computer file. And in this case, because I need to reference geometry that is on the radiators and the graphics card, etc., I would actually choose to probably just get the fittings that I know I want to use in place in this subassembly, and then bring that subassembly into the computer file and draw my pipes from there. So let's go ahead and let's say we want to have this one as an outlet that is feeding into the pump. And let's say we need to have that back one right here on the sides as an inlet where it's returning from the radiator. So I'm going to insert this and let's rotate it around. And let's join it. Here, J, enter. And let's bring another one in. And we could have mirrored it over. That's okay, but this isn't like a really complicated part. So it's no problem just to create multiple joints. And let's go J, enter. Okay, so I've got an inlet from this side and an outlet from this side. Now theoretically this one isn't exactly necessary, but in my design I created a little valve between them, which allows me to run a valve up to the top of the computer, or I can fill it up. So I can open that to let air into the system and close it to seal it off. So that way I never have to get inside here and try to fill my reservoir from like this little top port here. So I can just have a valve that opens up, lets air in. And so I'm going to go ahead and put a fitting there. And there's one more fitting I'm going to do, is I'm going to put some caps on these other ones so that way they don't leak like a sieve. So let's go back to my PC folder, pull up fittings, and we need just the cap. Just like right here. I think that one should be good. Let's check. Yep. So let's drag. Oh wait, we can't. We have to create a copy of it. So copy into water cooling loop, fittings, copy. And then let's go back to our water cooling loop, fittings. That should be in here now. And I can now drag that in as a linked file. And let's go ahead and bring this up. Mate this to the top. And I'm going to do this to all of them, so I will see you back here in a second. Okay, so I've got all of those closed up now. Thanks for bearing with me on that one. And one little pièce de la résistance, I'm sure I butchered the name of that, is let's go ahead and add in some water. And that's going to be a really cool little final touch. So let's hide the glass and let's create a new component. And we're going to say water, or let's rename it to coolant. So rename, where is rename? All right, we're just going to click there, rename, and we're going to sketch on this front surface. And we're going to project in that line from that body. And I'm going to create a spline. And I know you guys know that I'm not a huge fan of splines, but I think this is a great quick use for one. And let's create like that. Hit enter. We're going to use a fits point spline. And then I'm just going to drag this like that to kind of create a little wave in there as if the water was kind of turning. And then that'll be good. I'll just select that and go fix, unfix. And we can now extrude that into the back of this. So let's open up our bodies and hit extrude to object, that back surface, because we want it above this little water line right here. And then what we can do is we can hit an appearance, and let's look up liquid, and let's do water clear. And I can either leave it like that or I can change the color. So let's do like a red to match the kind of the color scheme. And then this absorption distance is how dense is that water? How effectively does that water let light through? So let's do like 100. And oh, I don't want 100 inches, I want 100 millimeters. Will it let me? No. Okay. So we're going to do 100, that's like 4 inches. Okay. Let's try rendering that real quick and see what that looks like. So render. And let's make this the front. That curved view is front. Change our scene. See if we can get some light shining in there a little bit. Oh, back. There we go. Okay, and let's see how well that lights up. It might be really dark, it might be really bright. Okay, that's actually very bright. So what we can do though to make it shine a little bit better in there, and this is a really neat trick a lot of people don't know about, is I can use internal faces of here as an LED. So if I hide this, I have this component right here, which is that little cap, right? Or this back one up here. So let's do that one. If I hit my appearance tab and I type LED, I can do like a 5000 lumen white, And then if I select faces, I could add an LED to just that little back face. Let me see if I can select it here. Come on. Faces. Will it let me? It might not because it's a linked file. So what we're going to do is we're going to take this one and we're going to break the link. Let's go back to design and let's break the link on that one. Just that one. Then go back into render and apply an appearance to that face of LED like that. So the other ones don't have that LED applied to them, but this one does. So that was a useful way to break the link. Hit OK. And the LED doesn't show up when you're just looking at it like this, but it does show up when you render it. So let me go like this and hit render without the actual water in there. And now you can see that the inside is lit up a little bit. So if I bring back that water, now you can actually see the LED reflecting off the top of this surface right here. So that's a cool little feature that a lot of people don't know about. That's an easy way to add lighting to your designs, is to use specific internal faces as an LED texture. Okay, so the last thing we're going to do before we close up this video, because we've kind of showcased how you can use both a bottom-up and a top-down approach in this video, is we're going to create a new assembly where we have two of these and we're going to join them together with some fittings. So let's go ahead and hit save this. And then we're going to go new design. And let's pull up our data panel and go back to our water cooling loop. And let's now add in the reservoir. So now the reservoir is going to, I need to save that first, sorry. Editable documents. Okay. And let's go back to water cooling loop. Save this. And now we can add this reservoir into this file. Sorry for that. So let's hit OK. And right now, this is a component that can move anywhere in space. It's very good practice when you're building an assembly like this of multiple subcomponents, or sorry, subassemblies or parts. The very first one in the top of your tree should be grounded. What that does is it effectively joins it to the origin point of wherever it currently sits. Another way to do this is you could open up like your origin point right here, and you could join that to the origin point of your design and effectively do the same thing. But ground is a very lightweight way, like calculation-wise, a lightweight way to do that. So now this can't move. Well, this one can because we didn't join it. So let's join those. Actually, we need to join that in the other design. So let's go back to the reservoir. We forgot to do it here. Join. Hit OK. Save. And now let's check it in the other one. So let's update that. And good, I can no longer move it. So the joints carried over from the previous component. And let's bring back our glass. Okay, so now we have one. So now we can either drag this in as another copied link, or we can just copy paste this. I'm going to go ahead and drag it in. So we have two. Hit OK. So this one can't move, but this one can. And what we can do is we can join these two, because this is what we care about. We care about the mate between these two holes. We'll join these together. You'll notice it didn't show the whole body, but that's okay. And then what we can do is say, how far apart do we want these? Okay, so consulting with my design on my other screen, we need them to be 42.6 millimeters separated from each other. So negative 42.6 millimeters. And that will set this. So now these can no longer move. And now we can add in like piping between them. So like, let's say I didn't want to have that valve and I just wanted to add like a copper pipe to join them. So I could create a sketch, let's say on, let's hide this other component. I could create a sketch on this plane right here. Oh, let's look at it from the side and project that in. And I just want to grab this one right here. And so we will extrude that as a new component, not a new body. So that way we can hide them separately. And we want to now reference the inside face of this one. So we will go to object here. So you'll notice now we are actually back to top down. So we built the body and this glass as top down. And then we added in the bolt and the fittings as bottom up by having them as separate part files. And then we added in this reservoir. It looks like these bolts got a little messed up, so I might have to fix that. But we added these back in as a bottom up, as a subassembly. And now we've created a pipe that is referencing in the context of this assembly. So this is also top down. So if I join these together, I need to join the outer circle here. Like that. Hit OK. And let's make it like polished copper. So let's do copper, polished, like that. And now I could have a pipe joining those two together. So all I would really need to do now is take this assembly, let's save it. And then so I've got my fittings, my bolts, the reservoir, and the subassembly of both reservoirs together. Now I could take that whole thing and drop it into my computer design, in which I could join it and locate it where I want it, and then just start creating all the piping going to all the individual components and the radiators, etc. So bringing up my previous design, you can kind of see what I ended up doing here. So I didn't have the copper pipe between, but I had the valve. But I inserted these subassemblies of the fans and the radiators, and I inserted the subassembly of these two, and I inserted the pumps and the motherboard, which is a subassembly with all the various components, and the graphics cards, which is a subassembly with its various components. And then in this file, I could start creating piping linking between all the different components based on where they were joined or mated to. And so that was a really interesting way of doing both a bottom up and a top down, because I did bottom up by bringing in the separate part files, but I also did top down by drawing in components that were exclusive to the context of that assembly. So, in summary, bottom up is kind of like building Legos. You build your assemblies with individually modeled parts until you have your finished product. By contrast, however, top down would be like starting with a single Lego and designing all the other Legos that connect to it in the same file. But really, the magic happens when you understand these concepts and can utilize each in different areas of your design. So I would like to thank Sebastian from my Discord server who requested this topic. I hope this helped you on understanding the differences between bottom up and top down, as well as best practices for reusing common components between designs. If you'd like to support my channel and help me to continue to produce high quality content, you can find me on Patreon at patreon.com/Austin Shaner. If you'd like to reach out to me with any questions or get help from me or other viewers on problems you are experiencing in your designs, you can join our Discord server or shoot me an email. Links will be in the description below. But thank you so much for coming. I hope to see you all in the next video. This is Austin, signing out.